Hi, today I will be solving an electrostatic problem. This one states that two identical balls of mass m equals 0.005 kilograms are attached to an insulating threads of length of 0.5 meters and hung from a common point. One ball had the charge of Q1 equals 1 microcoulomb, and the other had a different charge of Q2. The balls separate such that each thread makes an angle of 20 degrees with the vertical. And here's a picture depicting that. Our question is to find the charge of Q2. Now, if we examine the forces acting on one of the spheres, it's important that the force of gravity must be canceled by the vertical component of the tension, and that the electrostatic force must be canceled by the horizontal component of the tension. So, we're going to have two equations to start off with. We're going to have mass times gravity equals our tension times cosine of theta. Our second equation will be Fe, which is our electric force, equals our tension times sine of theta. Now, rearranging this equation, we could get our electrostatic force equals times mass times gravity, and then sine theta over cosine theta. Now, we will get back to this equation and use it in a moment. So, the magnitude of the electrostatic force is given by Coulomb's law equation. And this equation is the electrostatic force equals our K value, which is Coulomb's constant, times Q1 times Q2 over our distance squared. Now, rearranging this equation, we could get K to equal Q1 times Q2 over 2 times our length times sine theta, and all that will be squared. Now, rearranging the equation to solve for Q2, we will get Q2 equal 4 times our length squared times mass times gravity times sine cubed theta all over K times Q1 times cosine of theta. And simply plugging in the values that we were given in the original equation, we will get 4 times 0.5 squared times 0.005 times 9.8 times sine cube theta all over 9 times 10 to the 9th times 1 times 10 to the negative 6 cosine of 20 degrees. And then solving for this, we will get 2.3 times 10 to the negative 7 coulombs, or 0.23 microcoulombs as your final answer.